Hi everyone. In the previous class, I have explained very simple kind of functional equations, how to solve those functional equations of single variable. Now in this class, I am going to explain some standard functional equations without solving them. There are some kinds of functions which satisfy certain kind of relations. For example, you take log x. We have studied that log AB equal to log A plus log B. Or some exponential law like A power x into A power y equal to A power x plus y. A power x plus y. Or if you take that AB whole power n equal to A power n into B power n. So by taking these kinds of functions, we will check that what kind of relations will be satisfied. That I'm going to explain, and this class is very, very important with respect to JEE Main as well as JEE Advanced. So to remember these solutions of functional equations, I'll give you a very few basic things which help us to find the solutions of some functional equations. Like a very basic one, I'll write here. What is log AB? What is log AB? That logarithm of product of the numbers equal to log A plus log B. So here the operation logarithm converts sum to product. Product to sum. It converts product to sum. We give the input product and we get out the sum of outputs. Of course, where A and B are positive. Those are understood. Another one is like A to the power of x plus y. A to the power of x plus y. So this we can write that A power x into A to the power of y. This is like converting sum to product. Sum to product. And third one that AB whole power n. AB whole power n equal to. This is A power n into B power n. This is like a product to product. Product to product. Product to product. First one is product to sum. Second one sum to product. Third one is product to product. And at last, that we have that sum to sum. Like sum to sum. I can say that A plus B equal to A plus B. Okay, sum to sum. Okay, instead of solving a given functional equation, indirectly, we are by taking solution and will frame the functional equations. Okay, this is the reverse strategy, but this is not the actual method for Olympiad. So for our JEE Main and JEE Advanced, we do not require sometimes any kind of rules. We'll just study outlines of functional equations. Now you see that f of x equal to k into ln x. This is the given function. Well, now we'll check that what kind of relation will be satisfied this f of x equal to k ln x. Very simple. Listen carefully and apply these functional equations to solve certain kind of questions. Now you see, here x is positive. Okay, it is defined only for positive real numbers. Here x belongs to R plus. Well, here you say, let x comma y belongs to R plus. Okay. What is f of xy? What is f of xy? It is like a composite function. So f of xy equal to k into ln xy, k into ln xy. Now we know that ln xy can be written as ln x plus ln y. So k into ln x plus ln y. Got it? Okay, okay. Now, so therefore, this implies f of xy is equal to, it's so simple. We need not to worry at all about these standard functional equations. There are maximum four. There are maximum four, and those four are highly valuable in JMain. So therefore, f of xy is equal to, we can write that k into ln x, okay, plus k into ln y. Only the point is, we have to listen the class very carefully. So here k into ln x is nothing but f of x. Got it? K into ln y is nothing but f of y. So that this we got that f of x plus f of y. Wow. So we got some kind of functional relation. Functional relation, or you can say it is an equation. So what did we get? Therefore, which function satisfy this equation? This is the relation where x comma y belongs to R plus. Okay. It is called functional equation. Okay. An equation involving unknown functions. Functional equation. An equation involving unknown functions. Right? So this, what is the solution of this function? Implies, okay, the function satisfying f of xy equal to f of x plus f of y is f of x equal to ln x. F of x equal to k into ln x. This is equal to k into ln x. Or you can take that k into log x base a. This is very, very important. This is a very, very important. So therefore, f of x y equal to f of x, okay, or no. I am unable to draw the line exactly. I'll try that. Oh no. Okay, I'll leave that. I don't want to make it in the box. I'll just write like this. Okay. I just want to have a bigger picture. So now once again, you remember f of xy equal to f of x plus f of y. It is converting product to sum. So that function is f of x equal to k into ln x. This is the first one is over. And what kind of ln x satisfies? Ln a by b equal to ln of a by b equal to ln a minus ln b. Ln a minus ln b. So I can write that also. Second one. F of x by y, f of x by y equal to f of x minus f of y, f of x minus f of y. X comma y belongs to R plus. They are positive real numbers. Now, what is the solution of this function? As you know that log of x by y equal to log x minus log y. So the relation satisfying this equation is given by, not relation, you can say function. It is k into ln x, because ln of a by b equal to ln a minus ln. Oh, no. This is the previous class. All right. ln a minus ln b. ln. All right. Okay. Right. So we have learned two functional equations. One is sum to product, sorry, product to sum, and quotient to difference. Quotient to difference. For both, there is only one solution of f of x equal to k ln x. Okay, k ln x. Oh, sorry, I don't want to say there is only one solution. There may be some other solutions, but we do not require it right now. Okay. Functional equations are so typical, in fact, but we don't study that much high level. What is the third one? What is the third one? And after this, I'll solve a few questions of JEE main. They are very direct. They are very direct. And the next one, we know that a to the power of x plus y equal to a power x into a power y. Okay. Take f of x equal to a power x. We take the exponential function. Of course, we always assume that base is positive. Base must be positive for exponential function. All right. So this a to the power of x plus y is nothing but f of x plus y equal to f of x into f of y. This is sum to product. This is sum to product. The first one is product to sum. This is sum to product. All right. So another standard functional equation we have uh, derived that f of x plus y is equal to f of x into f of y. In most of the exams, you will find this model very frequently. Very frequently. So therefore, f of x plus y equal to f of x into f of y for all x comma y belongs to R. In the previous one, only R plus. Okay, implies what is the function satisfying this relation? The function satisfying this relation is a to the power of x. Remember, this functional equation is a very, very important. And it is so simple. You try to read out many a times. You try to solve the questions based on this formula, some 4 or 5 questions. Then automatically you can remember. You can remember. It will be stored in your brain. Well, so what is the role of f of x equal to f over x? It converts that sum to product f of x plus y equal to f of x into f of y. F of x into f of y. This is very, very important. And the fourth one or no, third one is over. Now fourth one. Fourth one. So what is this fourth one? Okay. Fourth one is 2 over product to sum to product. Now product to product. Okay. So f of xy, f of xy equal to, I am writing directly that f of x into f of y. For all x comma y belongs to R plus. No, sorry, R. Then this implies you will get that f of x equal to some x power n function. X to the power of n, where n is not necessarily an integer, right? So here, as I have said that f x comma y belongs to R, it's not R plus. So I'll take that any positive real number. If I did not mention that for all x comma y belongs to R, then you can take even 1 by x also. 1 by x bar. And this is also very, very important. You can verify it. If you want, you can verify it that what is f of xy. Okay. This is nothing but xy whole power n. This is equal to x power n into y power n. Nice. Over. All right. Okay. And one more is left. This is a very, very also, it is also very important, known as Cauchy's functional equation. It is the Cauchy's equation. He is a very famous mathematician. Cauchy's functional equation. Functional equation. So only one is left, that converting sum to sum. Converting sum to sum. That f of x plus y. F of x plus y equal to f of x plus f of y. Sum to sum. F of x plus f of x plus y equal to f of x plus f of y. The solution of this function is f of x equal to k into x. For this, the solution is f of x equal to k into x. Remember, I am not at all going to prove these functional equations in this video. Maybe later on I can provide the solutions of these functional equations, but they are a little bit difficult. Of course, if we can use continuity and differentiability, then it is easier to prove them. Maybe I'll do that. So f of x plus y is equal to f of x plus f of y implies f of x equal to kx. And one more, that functional equation, if f is a polynomial, if f is a polynomial, okay, f is a polynomial, of degree n, okay, or you can say of degree n, and it satisfies that f of x into f of 1 by x equal to f of x plus f of 1 by x. This model is also very, very important. F is a polynomial. Okay. Maybe this is a little bit difficult to prove it, in fact. I'll see, I can prove it. Okay. So what is the function satisfying this functional equation? So if you listen the class once or twice with 1.5 speed or 1.2 speed, easily you can understand, you can solve the questions. Everybody can understand. So the function satisfying this equation is a polynomial of degree n. We get that 1 plus or minus x to the power of n, where n belongs to n. Where n belongs to n. Of course, I am not taking any constant. Even you can take constant. All right. So we got it. F of x into f of 1 by x equal to f of x plus f of 1 by x implies f of x equal to 1 plus or minus x to the power of n. Okay. I'll solve 2-3 questions based on those functional equations, not more than 4 questions. I'll solve 4 questions. Okay. And in this, for the following questions, we required that sum of GP. Okay. So I'll write that GP formula so that we can solve the questions at our ease. So A plus AR plus AR square, okay, plus and so on. Sum of n terms of GP formula, AR power n minus 1 equal to A into 1 minus R power n by 1 minus R. For R not equal to 1. For R not equal to 1. This is the GP formula which I am going to use to solve a certain kind of problems asked in JEE main, especially based on these functional equations. Yes, thank you for watching the video. Let f of x plus y is equal to f of x into y. This is converting sum to product for all x and y. Suppose f of 5 equal to 2 and f dash of 0 equal to 3, then what is f dash of 5? This is the question. All right. We can solve this question at a very fast rate that the function satisfying this equation is very simple, that sum to product, that is a to the power of x. A to the power of x. All right. Okay. So this implies here we have given that f of 5 equal to 2. F of 5 equal to 2. F of 5 equal to 2. All right. So this implies a to the power of that 5 to the power of x, 5 to the power of x equal to 2. All right. All right. And what is f dash of x? What is f dash of x? F dash of x equal to a to the power of x log a. They have given that f dash of 0 equal to 3. All right. Okay. So first I will use that fact and I'll remove this second fact. I'll use that. F dash of x equal to the derivative of a power x equal to a power x ln a, and f dash of 0 equal to 3 implies put x 0, okay. So you will get that 1 into ln a equal to 3, right? Or you can say that, or a equal to e to the power of 3. So a value is e power 3. So therefore, what is f of x now? F of x equal to, you will get that e to the power of 3x. Okay. So what is f dash of 5? F dash of 5 equal to 3 into e to the power of 3x. Okay. F dash of x equal to, and f dash of 5 equal to, this is equal to 3 into e to the power of 15. Okay. That one condition I am removing. Otherwise, I feel that the question has no solution. I am removing that f of 5 equal to 2 condition. I am keeping one condition to find that constant, that is f dash of 0 equal to 3. There may be some other solution satisfying both, but my intention is to solve this question with the standard functional equations. Coming to next question. Come here. You see that f of x be a function satisfying again sum to product. Here given that f of 1 equal to 3. And they have given that sum of f of k from k equal to 1 to 9 n to n is 3 to 7 9. They are asking what is the value of n? What is the value of n? What is the value of n? So it is obvious that f of x equal to a power x. Immediately, without thinking, immediately. And f of 1, they have given 3. Put x1, you will get a equal to 3. So now what the function we got? That f of x equal, we got 3 to the power of x. Wow, very simple. Now put in the sigma. It is a very simple one. Sigma k equal to 1 to n. What is f of k? What is f of k? Nothing but sigma k equal to 1 to n. It is nothing but 3 to the power of k. F of x equal to 3 power x, f of k equal to 3 power k, f of a equal to 3 power a. Just variable is changed. So now I can write this as first term is 3, second term is 3 square, third term is 3. Sorry, first term is 3, second 3 square, 3 cube, up to n terms. So sum of n terms of GP. First term is A. Okay. There are n terms. Common ratio is 3. 3 power n minus 1 by 3 minus 1. Here common ratio is 3. First term is 3. And this is equal to 3 by 2 into 3 to the power of n minus 1. They have given that 3279. 3279. Now, I think we can cancel by 3. Okay. I'll try to cancel by 3. That 3 ones, 0, 9 and 3. 1093 and multiply by 2. So 3 power n minus 1 equal to 6, 8, 1, 2. Implies 3 to the power of n equal to, you will get 2187. Okay. As far as my knowledge is concerned, that 3 to the power of 6 equal to 729. 729. So what is 3 power 7 value? Multiply by another 3. 7. Okay. And that is 2. 3 to 6. 8. 2187. So therefore n equal to 7. Solved the question. If you did not understand, listen it again. But question is not at all difficult. And one more question of previous JEE main on functional equation. We have done that product to sum. Product to sum. And sum to product we did it. Okay. Sum to product we did. Here sum to sum. This is sum to sum. Sum to sum. So here that f of x equal to kx. Sum to sum. This is a Cauchy's functional equation. F of x equal to kx. They have given the condition that f of 6 equal to 18. Okay. So 6k equal to 18. Nice. We got the solution very directly. K equal to 3. So therefore, the function satisfying the relation is just 3x. Wow. Very nice. Now just plug the values. What values to be plugged in the function? 2 and 3. So what is f of 2 into f of 3? That's equal to 6 into 9. That's equal to 54. Finished. You please try to solve some more questions based on functional equations. One more. This is again sum to sum. So here you see, this is sum to sum. So here the function is f of x equal to some kx. And given that f of 1 equal to 2. So f of 1 equal to 2 implies you will get that k equal to 2. So therefore, f of x equal to the function is 2x. What is g of n? What is g of n? G of n equal to here. Look at here that summation of f of k. Summation of f of k. K is running from 1 to n minus 1. So what is f of k? F of k is 2k. Right? Except 2, this is the sum of first n minus 1 natural numbers. Sum of first n minus 1 natural numbers, that is n into n minus 1 by 2. Sum of first n natural numbers is n into n plus 1 by 2. They have given that g of n equal to 20. They have given that this is equal to 20. So which means that even by verification, you can solve this question n equal to 5. Thank you for listening my class. Please subscribe my channel and share to as many friends as you can.